All right. Welcome to another episode of Demo Days. I'm Hubert. I'm a DevRel at Decodable. And today we're going to look at COVID-19 rates, infection rates throughout the globe. This is the pipeline I'm going to be building today. Actually, I've already built it. I'm just going to walk you through how I built it. It's a very simple pipeline, but it does, at the end, when I show you the dashboard, it really resonates as to how bad it is sometimes out there. But you could do this with almost any kind of feed, build some really nice dashboards, get some really nice insights. This is just an example. I apologize for the sniffles. I do have allergies. I am outside, but that doesn't matter. I get allergies inside as well. So this is the picture. This is the diagram, the flow of the messages. I have some applications, some microservices scraping or pulling some, basically aggregating some COVID statistics available out there, free and some with a subscription. That is pushing data into Decodable using this REST API. So this REST API will just send it to what we call a stream inside Decodable. A stream is basically a place where data is kind of cached or held, or like it's like a table. And the other components connections bring the data in, and then pipelines transform that data in between these streams. Okay, and we go to another connection to sync it somewhere else. In this case, we're putting it in Apache Druid. It's a real-time OLAP database where you could do some really fast aggregations and queries of real-time data, so that we can build a visualization in or a dashboard in SuperSet that is truly real-time. Okay. The first thing I would get started with, if you follow with Decodable, there is we have a repository. Just go to Decodable CO examples. There's tons of examples in here. This one's called Apache Druid, or just Druid. This is how you really get started. I'll just let you know that the Kafka we're using is Confluent Cloud, but you can swap that out with Red Panda, Pulsar, or whatever. And likewise, the REST API, if this is something you don't want to use, you're already sending your data into Kafka, we could pull it out of Kafka, Red Panda, Pulsar, Kinesis, and so on. So you're not bound to this pipeline. You can always change it around. What we're trying to really show here is how easily it is to cleanse that data, so that Apache Druid can focus on fast queries instead of having to aggregate and clean that data first before serving it to the real-time dashboard. Here in this environment file, you just need your Decodable account. This configuration here, is a configuration that builds this really. But anything here, if you're going to swap out your streaming platform, you can put it all in here. Yeah, so this is the Kafka topic. So everything is pretty easy. You can fill that out, and all you would need to do is just make a flow, and it'll this flow will get you to a point where it'll start working with the transformations. It'll start consuming that data, and so on. We do have the application here that you could use if you want to modify it. It is a Python script. It's not very complex. All it's doing is taking a snapshot every hour, see any changes as to the infection rates in all the countries globally. So let's get started. Let's see what this looks like in Decodable. So I'm in my Decodable account. This one's called Decodable Demo. Let's start off with the connections. Two specific connections here I would like to show you. One is the source. That's the beginning of the flow of the messages. This is the sync. This is where it sends it to Confluent Cloud and then ultimately into Apache Druid. So click here. This is just it's just a REST API. There's nothing really here to show except for here. This is the decodable endpoint for your specific REST API. So when you create one, this won't get populated until you actually save it. You have to go in here and request or just copy paste it to your applications to start sending data to Decodable via REST API. This is the schema. I predefined the schema. This is what it looks like when it comes from the APIs that I'm pulling. You can see there's an ID. This is just a generic ID. Country and a country code. We'll look at that in a second. A slug is not really that important for our context here, but all these other metrics here is what we'll use to populate our dashboard. And this date here is really important. This is what Druid will need to know when where to assign those timestamps so that it could do date filtering and grouping and so on. And this is an extra field that the APIs provide if you have a higher premium account. I don't, so this will be empty. So I will probably want to, well, I will just filter at that field out. So let's go look at that stream. This is the real-time stream coming in. So here are the metrics, and this is the date time. I'm going to focus on this for a second because that's not in a format that Druid likes. And in fact, we want to, inside Decodable, this is just a string. So inside Decodable, we want to translate that or cast it into a real date and time or timestamp so that we could do our own manipulation with it. The Apache Druid would actually take this information and know that it's a timestamp and start processing. And I'll show you that when we get further down the pipeline here. So this is the stream. Remember, this is where things just land. Your data lands. And if you want to process it, there's things that this is the thing that can process or transform that data. It's called the pipeline. This is I named it COVID cleanse. And see that it's consuming from that stream and it's going to output to an outbound stream. And what it's doing in the middle is transforming using SQL. Okay, I've omitted that one extra premium row, but everything else I've kept, and I'm transforming this date timestamp. It's converting it to this is typically the format of like timestamps when you serialize it as JSON or even XML. This will convert it internally inside Decodable to a timestamp. So it's taking the date field, transforming it and converting it, downcasting it to a timestamp and keeping the date name column. You can actually preview this if you are debugging your SQL statement. You could run it. I could force some data to go through as well. And we'll see that as you're manipulating this SQL statement, you can see what it looks like so that when you actually publish it, it's the correct format or it's what you expected. Going to the next. So this is the stream. So again, this is where things land. So the pipeline doesn't actually hold data, it transforms data, but it lands in your stream. And this is just a stream or like a bucket, if you will, of your data that's been transformed. And this is now being consumed and sent to a Confluent Cloud, which is configured, which the Druid is configured to read from. So let's go to Druid right now. I have a couple of, so this is the Druid dashboard. I have a couple of data sources. One's COVID that I was speaking of. Another was from an old demo. If you look at this, you'll see that it understands the schema that we defined in Decodable. So what I want to do is just kind of walk you through how to get that inside Druid. If you created a specification, you can use it here. So if I wanted to look at my previous configurations, I click here. Or if I want to start a new one, I can just click this one. You see, I can pull it from multiple places. I want to use Kafka here. There's some moving around some things here. So connect to data. So in the GitHub repository, there is a template here that you could use. You could copy this. This is just the Bootstrap servers to your Kafka cluster, API keys and secrets, and a schema registry if you are using that. If not, you don't need that. You can just omit some of these values here. And that's what you would put inside here. Okay, so I'll just show you. I'll just give you an example. I'll copy the raw, and I'll paste it inside consumer properties. Notice that the UI parses the JSON and automatically loads. So if I just put my own value in here, it recognizes it. Right? Also, I didn't put a topic in here, so I would put this COVID topic. And actually, let me just grab what I have on the other one. Well, actually, so when you click apply here, it's going to reach out into Kafka and actually pull that data out. And what will happen is you'll walk through a couple of helper steps to identify which field is the timestamp. When you do that, it'll automatically pick the timestamp that is here. It recognizes that it's a timestamp. It'll ask you, do you want to use this as a timestamp? You say yes, and then that's it. Then you deploy that data set. What happens here is that I'll show you my previous spec here. If it's still going to. Not completely familiar with this UI yet, so this usually is populated with the previous properties, but this time for some reason it's not doing that. So let's go into ingestion, and we'll look at COVID data here. This is the configuration that gets generated after you've gone through the wizard. It knows the timestamp. It'll start to associate these properties in here. You don't have to build this. It builds it for you. So it's pretty simple to use. And in real time, you can see these are actually indices, but these in data sources, you can actually see the data itself. That's the schema. Oh, and the query, I mean. So we can run this query. So this is the last 24 hours. Notice that the US is in here twice, France or Germany is in here twice, Japan's in here twice. That's because it's run more than twice in the last 24 hours, and the numbers have changed in between those times. If there was if that post was run again and it was the same confirmed numbers, Druid actually knows how to recognize that as a duplicate. So this is actual increases of COVID rates, infection rates in the US. Okay, so you can actually change this. That'll be the last 24 hours. This is important because we use this inside of SuperSet, our dashboard, to just get the last 24 hours of data, because that's what our dashboard really cares about. So let's look at the dashboard. Let's do a quick refresh here. So this is the dashboard. This is the timeline. There was a significant drop on the 11th. And then after that, I forgot to renew my subscription to the API, and I lost a couple of days of data. So I should have been paying attention to my my emails and decodable alerts, and I wasn't. So I renewed it today, and this is we see quite a big jump from the 11th to the 14th. The US here, I think, is around 275, maybe 280,000 rates. I don't know how these rates, some of these rates don't make any sense. I don't know if they're cumulative or snapshots of the previous day. It's hard for me to believe, although I'm not an epidemiologist, that we got over 280,000 infections in 24 hours. But I could be wrong. Either way, it looks like there's things are happening. There's a lot of colorful, like, dark areas here. This is actually 276,000. This is the total since the beginning of the pandemic. The heat map. These are using different views of the same data sets, right? So from that same data set, from using Druid and the SuperSet, I can build a timeline. I could build a heat map. This is basically a heat map with a map view. So how did I do this? Let's go to the databases. You can see I have a few real-time databases here. The one we're concerned about is Apache Druid. So all you would need to do is click add a database and look for Druid here. And you would paste you can see it in here, the syntax. You type Druid plus the username, password to Druid, the host, port in the database. If you use it underneath, it uses SQL Alchemy as it says. So just do a quick search on SQL Alchemy, and you get the right URL for your real-time database. If you want to look at mine, it looks like this, Druid. There's a secret in there, and so on. Okay. Next thing you would do is create a data set from that database connection. So you just click a data set. I could choose that database. It goes out and actually pulls that information. This one's taking a bit longer. Druid and my COVID. And I just click add. I don't want to duplicate this. I already have it here. Oops. I'll go back here. COVID, you can see that it knows, it just pre-populates the columns and so on. If there's something you need to change, you could change it here. I like to change it at the chart level. So if I go back to here and look at my infection rates, and I want to look at this dashboard or this chart here, I can go to edit chart. You could see that I'm using a filter here, and this is a filter that's specific to Druid. It's the same filter that I have in here that gives me only 1 day's worth of data. But that's what's populating the map, right? So to get me 1 day. There is a time range here. I've had issues with that. Doesn't work as well as I want it to. This filtering down here does work pretty well. I seem to get back down there. There we go. You set it to the settings you'd like. You like take these out here. I picked the country code. This is using a specific country code. There are multiple country codes here you can choose from, depending on the country codes that I'm using happens to be this one. So I don't have to do like a lookup as to what country it is or what code this dashboard understands. The API I'm using actually is providing me with the country code that SuperSet understands. Okay, and you can create a lot of charts here. As you notice, I have a lot of COVID related charts. and then build your dashboards using this kind of view. Also, if you want to join this up with, let's say, it's like IoT data, like coming from your phone, if you're going to a place or a city that you are and you're concerned about COVID rates, you know, you could join that data using Decodable and get alerts, or even populate that on the map. There's lots of things you could do with real-time data, as long as that you can use Decodable to join that data. If you have any questions, if you'd like to build something similar, definitely reach out to us. We're always open to helping out your real-time use cases. Thanks a lot, and see you next week. Hopefully, I think next week should be IoT, so that should be fun. Great. Thanks a lot.